Hello, Justin here from Tinman Electronics. BAM! I got a Elenco power supply from Amazon recently. I've been working on my workbench and I've really cleaned up the whole place. I'm ready to do some electronics. So I got myself a power supply kit, which I will be assembling shortly. I will step us through it, maybe get a time lapse going, but let's just check it out, see what I could do to it, okay? So here she is, the Elenco power supply. XP-720K. K is for kit. So let's open it up. Okay, and I guess here we get a assembly manual. So I mean, in case of emergency, I'm going to be using this, or if I can't even figure it out right off the bat, or maybe I'll just use it right off the bat because it's going to be safer. Oh man, and a banged up, look at that, that's not very nice. A banged up casing, look at that, it's metal and it's already bent. It came bent. I'll probably just hammer it out or something, kind of straighten it up, but that's a little shameful. It was only 60 bucks, but come on. So I'll put that aside. And as for parts, they seem to come inside a plastic bag. Here's the transformer, a big horker. This is actually probably the most expensive piece of the whole set, is this transformer, probably worth 20 bucks Canadian. Knobs, what's this? Oh, it comes with lead-free solder, which I will not be using. This will be going in the garbage probably. Elenco brand, that's ridiculous. It comes with some wire, some heat shrink. Let's just pop this open. Right, so solder, some kind of heat shrink. Looks pretty thick though to be heat shrink. Caps, passives, nuts, lock washers, Zehners, diodes, resistors. We've got chips. I bet there's a LM317 in here because it's a very simple kit. LM337, 317 of course. And no doubt, in order to get the current rating, which I think is either 1 amp or 3 amps, we got a heatsink for these guys. There's also the PCB, which is very small, and geez, look at that. I could have just built myself one. Come on. This is way too simple and pretty damn small. And the power connector. And in the bottom we've got the remaining part of the case. So let's check it out. Let's rip this open. And it's just as bent as the top part. So that is very, very unsatisfying. That's probably going to go in the review. But check that out. Up to 3 amps output. That's pretty good. Plus 25, 1.25 to 15 volts. Or individual 5 volts out at 3 amps, so that's pretty good. There's it's a dual power supply. You'll see that when it's done. Spot for a rocker switch on off, and this, which I don't know exactly why this is any significant, but 6.3 volts AC. Not sure. So yeah, let's start building it. And remember, don't forget your safety glasses. Don't want to get some lead-free solder in your eyes, that'll burn them out. This is great. This is great. Look at this. All organized. I got kind of like my soldering area. I've got my testing area where I've got my multimeter and oscilloscope. I'm gonna soon have my power supply to have right beside it, and I could just do all my prototyping right here. So this is gonna be a pretty sick setup. And seeing as the case came in pretty banged up, I'm gonna go through all the parts, make sure everything's here, because if they're not, well then it's really a big fail. I mean, I'm sure I could find pieces to finish this project because it's pretty simple, very like jelly bean kind of parts where you could just get them anywhere. So I'm not gonna return it or anything, but I mean I got to make sure I've got everything before I start this. I've only got about 2 hours before I got to go somewhere, so that's my deadline. Alright, so I think I'm actually ready to mount these components to the PC board, which is it's got this very ugly blue color on it, but I guess I'm gonna have to use it anyways. This might take a little longer than 2 hours though, because I've got to mount stuff on the chassis, the bent up chassis, and I've got to do some wiring and soldering in between the PC board and the chassis components like the binding posts. So we'll see how that goes. And there she is. That is the assembled PC board. It's very simple. It's got a single transistor on it with a bunch of passives. It's got diodes, capacitors, and resistors, and all I've got to do is basically hook up, solder all these wires to the transformer, to the heat-sinked LM317s, the voltage regulators, and then the binding posts, and that'll be done real soon. Okay, so I might as well show you guys the inside since I made it this far. So I just popped the cap open after assembling this, and I'm kind of looking inside to show you my very messy wiring. But there's the soldering job on the PC board, or sorry, the printed circuit board, the PCB, and there's the transformer. And they give you some really cheap ass. They give you some really bad heat shrink. Like I used I didn't have a heat gun in here, so I just used a hair dryer, and it even then, like I brought the heat gun to it after, and it did a horrible job at shrinking. And they kind of give you a piece too small. They tell you to wrap this piece of heat shrink right here over the rocker switch, but I couldn't do it because it's too small, so kind of pointless. The binding posts, you should probably get your own because these ones are kind of tough to solder on. They're not fun. You know, a nice binding post where you could insert it, kind of wrap it around, it hold it in place while you solder it. This was a pain in the ass. I had the helping hand kind of hold it if I could. I mean, these center binding posts here were very tough to get done. They also tell you, you might notice there's a piece of heat shrink right there, this little thing. Well, that's because they tell you to cut a piece like 3 inches, and that's not enough to get to the binding post. So I kind of just did a patch job because I already put the PCB, I mounted it on the case, and I didn't want to take it off and kind of resolder that. Just a waste of time. I just wanted this to be quick, and it turned out to be quite a waste of my time. So let's move on to the heatsink here. It's really ugly. It's horrible. I mean, there's seriously no better way they could do this. This is how they tell you to do it. This is spaghetti. That's crap. And like I kind of started with just not even tinning the wires. That was bad choice on my decision. But after I moved on to tinning the wires, like they said, it's horrible. Like there's not much clearance between the pins and the actual metal case, and it's a very simple circuit. You could just build this on a breadboard. And straight from the application notes. You just got to find the 317, the 337, the 7805, and whatever other transistor they have right here. And you could build this on a breadboard. All you need is just those chips, this transformer, and some variable resistors. Okay, so I'm finally ready to test this guy out. I'm gonna plug it in right now. I've got everything dialed down and turned off. Come to think of it, I actually have to put in the fuse, so do that real quickly. Just watch this thing explode. I mean, the transformer is gonna fry one of these caps. The largest cap, the 400 or the 4,700 microfarad cap in here, is actually smaller than the 2,200 microfarad caps. So I'm a little worried that this thing was probably not well designed. Obviously, they're at different voltage ratings, but let's find out. I gotta plug it here. I'm gonna put on some safety glasses just to be safe. I trust my own work, but the engineering part of this thing, I don't think so. So, okay, I just turned it on, and you could see the rocker switch actually has an LED in it, so that's kind of nice. So you know if it's on or off, because it doesn't make any noise. It's not active cooling, like it doesn't have a fan or anything. It's just a heat sink. Okay, so I guess let's try this out. The minimum voltage on this should be 1.25 volts, so just hook this up. 1.265, I guess that's the minimum I get. And I'm dialing it up, and you can see it going up. 2 over range. Keep going up. Oh yeah, that actually works. I'd have to do a current draw test, but I think it's safe to take off these safety glasses. Now for the negative supply, let's see that. Neg 1.25, right on. And you can increase that all the way up to neg 18, which is actually above spec. I should check the maximum voltage here. Oh yeah, 17, 18-ish, so that's pretty good. Again, I'll have to test out the current draw. Apparently there's this AC voltage thing. I'm just gonna test that out real quick. AC. Right on. Yeah, it works. And the TTL voltage, the 5 volts at 3 amps, shows pretty close to 5, 4.98. I think that's agreeable. I'm just gonna check what's in here for test specs, just to see what they think is good. Okay, so they're telling me I'm supposed to short the DC outputs one at a time to check to make sure that the current limiting is working. So I'm just going to do that, see if anything explodes, and if it doesn't, I'm just going to assume it works, because I don't really have any power resistors to do any of these measurements. So let's check it out. So, fuck. Ooh, that ain't pretty. And it's good. Let's try that again. Yeah, so I'm just going to go ahead and use it in my projects. It works as a variable voltage power supply, but if I ever encounter problems, I'm probably going to take a look at this first. And if not, well, then it's the project. So to conclude, I'm kind of going to say, don't get a power supply kit unless you kind of really want to get the experience of putting it together. It was more of a hassle than anything, so just stay away from it. Just get yourself you could get the assembled version of this for like $10 more. Probably worth it. It's probably done a better job than I have inside here, because there's the instructions that I kind of followed really make it for some kind of messy wiring in here, so keep that in mind. I just want to kind of show you the schematic diagram here. It's right in the back. It's the last thing they show you too, and check it out. It's just very simple. You've got your transformer, and it just goes through some bridging diodes, and that's about it. You've got your ICs. This is like straight application note stuff. If you purchase these chips and you look at their data sheet, it will tell you how to make this circuit. And yeah, like I've already done this with the 317 for my own projects, and it's very simple. They throw in the big caps on the input, and then they have a, what's this, 7805. They get a, I don't care what they're doing here, but they're getting 5 volts out with 7805, so check that out. I'm Justin St-Amant from Tinman Electronics. That's engineering.
Bam!